again to take off into space.
Free Coaching Friday.
Free Coaching Fridays, where you get to learn how to fly a TIE fighter for free. Let's get into it,
well,
everyone. First,
pick your ship.
You launch and
we're deploying.
Here we go. Oh, we're deploying. Oh, we're taking off for flight. Oh no. Are you guys ready for this? Because I don't know if I am.
Well, happy Friday, everyone.
Happy Friday.
While Nathan is flying his TIE fighter around space,
here we go.
We're going to talk a little bit about some things tonight.
Yeah, lots of things.
And Nathan's going to demonstrate, talk about some things, and I'm going to ask a lot of questions and show a lot of the things that I don't know, because I want to learn more as well. So let's talk, Nathan.
All right, we're gonna make this exciting, like a roller coaster.
Oh my goodness.
With spaceships, yeah.
All right. So first question: what is a home lab?
Okay, so a home lab is like if you want to learn how to fly a TIE fighter into space, you don't want to actually crash into a big giant rock and explode. So instead, you want to be able to test fly your ship, right?
Mm-hmm.
You don't want to just like go straight into space, never even touch one of these things, and probably just like fly straight into one of these walls at like maximum speed.
Oh my goodness.
Oh goodness. Okay, let's not do that.
Dangerous.
Let's not do that. But really, as you can see on the screen here, we have a home lab that we use ourselves for like our development, which comes from, I build home labs ever since I worked in the professional space. And, when you're working on multi-million-dollar infrastructure, you don't want to like destroy your multi-million-dollar infrastructure. It's best to have
and what if I don't even
stuff.
have like access to multi-million-dollar infrastructure? Because probably most people
Oh, that's a good point.
don't.
Oh, yeah.
Yeah.
Like, what if you're like a complete beginner then?
Yeah, well, I'm a complete beginner. I don't know anything. What is a home lab, and why do I need one?
Oh, well, if you're a complete beginner, then, the best thing to say about having a home lab, if you're trying to get into, cloud computing, for example. So we specialize in cloud computing. And if you do want to start getting into cloud computing, really, you want to have, a safe, not crazy place to just build your stuff, and really once upon a time we did have to have these big beefy servers and all this stuff, and that was pretty much required for people to do primary hosting for these big, you'd see these data centers and all that stuff with all the computers along the walls. Well, you don't have access to this stuff if you're just a beginner in the first place, let alone trying to simulate something for your job. You don't have a job to simulate. So instead...
Well, yeah, and probably you don't even know what simulation is and what that even means.
Yeah, so it's you can simulate all of the things that you can do. So once upon a time it was big machines, but now all of a sudden cloud is mostly built on top of what's called infrastructure as code. And infrastructure as code, if you've ever heard of something called Docker or Kubernetes or containerization, which if you're new to computing, you've probably never heard of any of these things. But basically what it means is that entire computers, if anyone's heard of a virtual machine, it's almost like instead of having a virtual machine, it's like having a little computer inside of a computer that's all software. Now, if you don't know any of this stuff or know what a virtual machine is, then it's all Greek to you and you don't even know what that is. But if you know what a virtual machine is, containers can seem and feel like virtual machines, but the real difference between virtual machines and containers is that it's software. And so yeah. Cloud has become software. And granted, the software still has to be housed in something. Software doesn't just run without having something to run it or something to host it. And then, just because you have good hardware or something that you can host development on or host whatever you're doing for a company, well, Google, for example, anything that you're using from Google, whether you're using Google Maps or all these things, the data that makes those little apps or applications work or run, it's built on cloud infrastructure, and it's built on what we're talking about. But if you wanted to go and say do that sort of job where you're building cloud and cloud technology for Google or one of these big companies, you can learn at home, because nowadays people use software for building cloud these days. And if you want to learn cloud, you can build your own lab where you don't actually. It's just like right here, and it's just like it's kind of like a video game, except for with technology, the video game became real, because like the same thing that you can practice with is the same thing as the real deal, and that's something like Kubernetes, which maybe I'll just show you real quick if I just like tab out of this.
Well, but wait a second.
Oh sure.
So we've talked have we touched on like why I need to have a home lab exactly? Can we summarize maybe what the reasons are?
Oh yeah.
Just kind of a safer way to.
Yeah, it's a safe way to practice things that. It's a safe way to practice, really, and experiment things that are either otherwise like you'd need to go ruin a multi-million-dollar infrastructure, but you don't want to do that. You want to practice. You want to be able to simulate and experiment and test. So really, it's a place for scientific experiments, which I can just
take
outline.
A flying leap. Oh, there he goes. Okay.
Let's just whiteboard a little bit of it. So, really, why home lab? We can kind of just outline a lot of this and kind of keep it on the screen here. So we want to build a place to develop or experiment. So that's a really good question, and definitely worth paying a lot of attention to. Is like, why do we want to have a home lab? Especially because, once again, if you are working for like some big company, like on their big systems, they're not going to let you play around and experiment with their production system. So even if you're a developer, developers have to actually have home labs. So when I was working in the development space, like I ended up, you talk to a lot of developers, especially once you go into cloud, who start knowing a whole lot. Almost all of them have their own lab at home for a reason, because you're not going to just go and just wreck the company's, expensive multi-billion-dollar
and they probably won't even
stuff.
let you near it anytime soon if you're kind of new in your career anyway. So
they don't let you learn on that.
Maybe helps you get a little bit of like a leg up, I guess. Is that what you're saying? Yeah.
And then the other thing is like, let's say that here's another reason is like, let's say that you want to build a new product or something along those lines. So like, so we'll say apps or products. So if you're trying to build a new lab or app or product, once again, like, you don't necessarily need to have everything ready for hosting an app. So like, let's say that you wanted to build something for like AWS or Azure and you really want to get into that. Great platforms, and the thing is that they cost money. And depending on what you're trying to build, a lot of the things that you can build at home, like in your own ecosystem. You don't have to pay a monthly fee until you're ready to start paying monthly. You can have something that basically, like, we work with home labs for a reason, because even for us, like, if I'm going to start building a piece of software, which we started building a piece of software called the Olympiad, for example, and in order for me to even build the Olympiad, I originally bought like a $6,000 system or something along those lines to build on, and then used somewhere in the realm of like $10,000 worth of infrastructure to start building and doing mock-ups on and all this stuff. And then all of a sudden, these little tiny like Raspberry Pis came out. And while I still use that system, we're actually streaming on it right now, and I've repurposed it for other things, and I use it for various types of hosts. Like, it gets used for business purposes. But ultimately,
the original purpose of development.
Yeah, it was originally going to be used for development, and now, like, I use it more actually, like, for like more production-facing things, like doing my live streaming productions and things that are a little more like customer-facing now, and stuff that, like, I don't really want this system to be used experimentally anymore. Now I use this more for like professional business use. So I'm not going to use my my $10,000 set of infrastructure for a lot of my experiments, because it's also cumbersome. It's a lot to move around. It's just much easier to have a smaller, more lightweight like way to just build whatever even goes into my larger live infrastructure. So
definitely,
yeah. So really, that's why it's just nice to have your own home infrastructure.
Sure,
your
sure.
own home labs,
Well, and you
those
talked
things.
about like it's great for building clouds and building apps and products. What are some other uses for a home lab?
So like other reasons why you might have a home lab, because you might build new apps, you might do different things. But really, let's say that you just want to start a career, right? Like, let's say that you've never had a career doing cloud development or anything like this. Then let's say you want to learn how to build a career, right? And so if you're trying to build a career, then essentially, once again, you want to have something that, whether you're more entrepreneurial, so maybe this is more of someone who's more of an entrepreneur. And then otherwise, like if you're just looking for a job, there's something called an intrapreneur, which is someone who's generally just as ambitious as an entrepreneur. The only real difference between an intrapreneur and an entrepreneur is that intrapreneurs sort of prefer to look for big companies to work for and do things with, and kind of work as teams and not be necessarily the one building, like being the leader of the team, but likes to be in the team, in the battle with everyone. And
or just, they want to work, they'd prefer to work for a company
or they prefer to have
start
a
their own
job.
business, which is a difficult and not always pleasant thing to do.
Yeah. It's not always, honestly, it's
depending
not
on your priorities.
It's not the most pleasant experience to build a business.
Entrepreneurs are generally more interested in just giving their talents to a company and helping a company better itself, essentially.
Yeah, exactly. So, getting into a lot of that, it's like, once again, like, why would you want to have a home lab? Right? Really, it just allows you to be able to do more in general. And so if you're trying to work at a company, and ultimately when you're trying to get like interviews and things like that, companies want to know that you actually know how to use stuff, and they want to know that you actually, like, if you actually experiment at home and you're in an interview and they're like, oh, so what do you do if you have something like this going on with your system, or if you have this kind of situation going on with your system? If you're tinkering around at home with your systems, you know why all of that is mandatory.
Definitely.
You're like, oh, this is really important. You're like, I know exactly what to do because I've had this happen in my home lab. And really, it's like, if you have your own lightweight cloud infrastructure, because basically we build like desk clouds. You have a little cloud on your desk. And if you have a cloud that you have on your desk that you've learned how to build, and you've learned how to build like all of the infrastructure for it, build it in like what's called infrastructure as code. Really, the other thing is, if you do build anything in a small environment, let's say that you end up doing this for years, right? Let's say that you do this or like end up tinkering around for like 5+ years. We wouldn't have to say that long, but like, let's just give it at least a year, right? Of just playing around with all of this stuff, playing around with infrastructure as code, all these bits. Inevitably, you're going to have skills that allow you to have like something to show for. So basically, you'll have like your own assets. And this is up to you for how you want to handle having your own assets. If you are basically building something that can be hosted online, the internet, whoever is a user on your internet, they don't care what their user interface is running on. Like this stream, like it doesn't really matter if I had this running from one of my OS X systems and I was doing this, or one of my Windows systems, or I could even flash one of these things to be Linux, or I used to run a number of streams from a virtual machine, which I still do. I even edit video from a virtual machine. We have all these things that under the hood, whether it's like under the hood of the stream, like what you guys are watching, or no one cares what it's running on. And so if you're just trying to build like a web app or a website or a mail server or a VPN server or some sort of server, and you're trying to just learn how this works, you end up literally, you have your own code, and so you end up with something called infrastructure as code, which is basically software. So basically you end up with your own software is what happens. your own
Wow.
scalable software. And one of the cool things about this is, let's say that you started developing on a small system, and let's say that someday you do want to go, once again, move to like AWS or move to some bigger, beefier stuff. Because at some point, when you have the money to get whatever you want, and maybe you do have money and you're just like, I don't care about spending my money on hosting. Maybe I prefer to spend my money on people, right?
Mm-hmm.
And maybe you want to if you prefer to put your money more on the talent and keep your infrastructure light, you can always just keep infrastructure lightweight. But still, let's say that you wanted to be able to make it to where like more people can use your little platform that you've been developing on. You can start to just hand other people these systems, and then basically like this is their office. All they do is connect to this. Bam, there's your whole office. Whether they're having their own computer VPN into these little ecosystems, and it's like building your own land. Basically, you could think of it like building your own land. But then in here
Definitely.
you get software that maybe you do want to go to AWS or Azure. Who cares? You can scale into that, and just because it's software, you're building your own software. You're building your own scalable software. And then it's up to you for how scalable you want to make it. But generally speaking, when you first start building things, it's only going to work on what you started with. But it's like, a good example of this is actually video games. A really good example of this is video games. Because if anyone's ever played a video game, let's just go to, like, I'm playing Star Wars Squadrons. I'm just going to go ahead and pull something up real quick and just say Star Wars. Just because that's what I'm playing. I'm not actually marketing or advertising this. I'm honestly just a really big Star Wars fan. So I'm like, yes, Star Wars. It might be a little tiny on the screen, but I guess I could pull it up like in a browser or something along those lines. Let's see if I can make that bigger. I can't make that bigger there. Let's try to make this bigger for everyone.
What does it say? You can just read it.
Oh, that's fine. I can just read it. So what it has here, and I'll just kind of read what it has. It says system requirements. This is the important part that I'm getting at, because this is software. We teach people how to build software, right? I teach you how to build infrastructure as software. So basically, like, using a computer to build software computers that you can then put on anything. So and that's the modern standard for supercomputing. So that's called Kubernetes. Is the modern, if anyone's ever heard of what cloud native is, and actually someone in our DevSecOps dojo, Jorge, one of our DevSecOps founders, because we run a DevSecOps dojo, made a good note about cloud native computing. There's something called the Cloud Native Computing Foundation, and I don't really talk about that very often, but one thing I just want to talk about when we're getting into software, because we teach people how to build software products, but infrastructure software, like software that's like, infrastructure as code. So we have system requirements even on this game that I was playing, and it says minimum, it says that you have to have Windows 10, 64-bit is what it says. But if we look at this, it says that you can use different processors. It says that you could use a Ryzen processor, an i5 processor, different types of Ryzen processors, an i7 processor. It says that you can have 8 gigabytes of RAM, or you can have 16 gigabytes of RAM. And one thing that I realize that I don't talk about a whole lot about is, with modern cloud computing and developing for modern cloud computing, you can build software on like anything that you can build the software on. Because you can, whatever the smallest thing that you start building software on becomes the minimum requirement. And so we built a platform called the Olympiad, and the minimum requirement for our Olympiad platform so happens to be one of these little teeny tiny things. And by the time we're done, because I'm going to be expanding that and scaling it to my, much beefier, like my $10,000 node set, right? This is like a much more affordable node. So this would be, in cloud computing, this would be a computing node right here, right? Mm-hmm. This is an infinitely more affordable node than my multi-$1,000 node that I'm going to scale my software to, right? And so for me, the thing on the left is our minimum software requirement. That's the minimum requirement, is we build these kits and teach people how to basically overclock these kits to the appropriate amount of power to build cloud software.
Sure.
And if you want to build cloud software, you would want to overclock these types of systems, but we build overclocking kits for a reason. So these are like overclocking cloud kits. This is an overclocking dual cloud kit for developing cloud. So you have to hack the hardware on these suckers, and we provide a whole workshop because we provide workshops on how to learn this stuff really. And then also we have what's called a DevSecOps dojo for those who already know a lot of this stuff and are trying to do something that's a little more advanced.
Definitely.
And maybe you just want to know how to get our kit set up, then we have the workshop to get the kit set up. If you're completely new to all this stuff, then congratulations, this is a great first time kit. But if you're trying to, actually this is not the first time kit. I would not recommend the model I'm holding if you're a beginner. The model in the picture is what I would recommend if you're a beginner. This is more of a professional model right here, so that's not something that I would actually
so the main
recommend.
difference between those two is the one on the screen has just one Raspberry Pi PCB, whereas the one that Nathan was holding has two. It's clustered together.
And to kind of clear up a little confusion, we're not saying that we're teaching you how to make hardware that can play Star Wars, because this is actually not for gaming at all. I guess my point is that cloud, learning how to build cloud is not much different from learning how to build a video game. You just decide what you want it to be compatible with, and then you build it. And so for cloud, there's a piece of software for anyone who's new to cloud. So first, I'm just going to bring up, because this is a great thing to bring up for anyone trying to learn cloud, is I'm just going to bring up a site, Cloud Native. So there's this website that basically, it's called Cloud Native. You can't really see the whole screen, I guess. Maybe I'll just move this around a little bit. There you go, Cloud Native Foundation. And if you're in the Facebook chat, I'll just paste the link to this. This is a website that's worth exploring and checking out, honestly. Because this is a place where, if you're trying to become a developer, or you're a company like us where you work with cloud technology and cloud platforms and all this interesting stuff, and if you're doing this stuff, then this stuff is probably interesting to you. But when we look at this, it has little listings for, projects, and it says like about, and it says certification. And we can look at this first option. It says software conformance certified Kubernetes, and we click on this. This right here is how you build cloud, well, how a lot of companies build cloud these days. Certified Kubernetes conformance program benefits. And so like this right here gives you a good insight on, okay, so how can I kind of figure out like what kinds of companies actually do the building of cloud, and what do people actually do with this stuff? Like who does this stuff? And when people are talking about like cloud, what is cloud? Like that diagram that we're looking at on the, I guess it would be the right-hand side of the viewer, where it says the Olympiad DevSecOps Toolbox. It's basically a software suite that's designed around what's called Kubernetes and Docker. Now, an interesting thing about Kubernetes and Docker is dog hair.
Everywhere.
Everywhere. Once upon a time, Kubernetes and Docker was something that people would install together. We don't actually run Kubernetes and Docker together. We develop for Kubernetes in Docker and run Kubernetes for production. So just as I was kind of talking about earlier, how I do development on something like this, and then I go and put it in a more production system, well, the production is Kubernetes. I put all the production, everything in a Kubernetes shell and container, and but I build in a Docker container, or a Docker swarm rather is what it's called. And that's just like a technical term, but you can start learning what these terms are, what these things are. But in terms of like the big companies, if you want to learn how to develop with them, the development suite that works really well, or at least my favorite development suite, and I teach with this development suite for a reason, is just like Docker. It's a great place to build things that you can import into Kubernetes. And if you look in the news and get confused by Kubernetes saying that they don't work with Docker anymore, the things that let you, the software that you build with Docker, they're called images, and these little images that you build with Docker are called container images, and Kubernetes uses container images, and actually the images that you build with like Docker and all these things, like they work interchangeably because of the way technology works. But that's why we built a class, and that's why you build a home lab.
Right, yeah.
Because without a home lab, nothing that I'm saying will ever make sense. Now, you don't have to actually buy anything to start working with the home lab, because we even
Right.
have, let's say that you have hardware and assets, and let's say that you can build with, like, Docker's a great piece of software to start with. Let's say that you have software compatible with Docker. You could go to, like, on our website, we've started working on this platform called the Olympiad, which is actually finally, like, ready for business use now, which we've done a lot of rigorous testing with various, like, people for, like, mostly like educators and also like small business suites, is where we've done testing for this little platform. It's basically just like a cloud on your desk, but this is an open source toolbox for anyone who can basically run Docker, essentially. So as long as you have at least something like a Raspberry Pi, then you can basically set up your own Olympiad development suite, like, for free. Like, that's something that you can just make because it's built off of the backbone. Really, the Olympiad is an architecture. We didn't necessarily build a specific set of software. We built an architecture that works for a very specific use case, and the Olympiad is a development architecture, is what it is. And if you want to learn it, and you want to get the kinds of jobs that make that possible, then that's the stuff.
Yeah. Okay, cool.
Confusing.
Very confusing. But one way to clarify is we do offer a course in all of this called PyTinker. But yeah, okay, so interesting. So what are some of the uses, some use cases for, like, the Olympiad software, for example?
So, like, some really great things about, like, good use cases is, for one, you can learn, which we've been talking about, or better yet, if you're an educator, it's sometimes really hard to figure out how you can teach, and you can actually host, like, training virtual machines and training access, and, like, host your own educational suite and site straight from your desk. And so if you're like an educator trying to teach people all this cybersecurity stuff, you can have your own cloud server that all your students can access and connect to, where you just give them a URL. You're like, okay, class, we're going to start class today. And now this would be a use case more for people who are doing business, whether you're like training or whether you're doing demos for someone, or whether you're anyone who's really like trying to do technical education. So maybe you're an educator. This might not be for beginners per se, but like it's a strong use case for like, you just want to teach, and you just want teaching to not be a nightmare.
Yeah.
And then let's say that you have other instructors that you work with. You can have the instructors VPN together, where then basically you have what's called a distributed cloud, where then you have multiples of these, which this is a something else for me to just represent a built one. But it's like, then you can give someone else, like if I were to just give Laura one and she were to be in another country somewhere, who knows where, and then we can have our own cloud that we teach from, where all the instructors can have their own lightweight infrastructure that they all work from to serve something for students to, work with and learn in, and really like a development lab. And even if they're not students, it could just be like you run a development team and you try to keep your development team trained, and you want to build like hacking simulations. And we actually have some videos. If you go and look at some of our old videos called Hide and Hunt. Yes. Hide and Hunt is a game that we made. So if you look up Hide and Hunt on my YouTube channel.
Yeah.
You can learn all kinds of stuff, but really, like, you can learn things like how to monitor your own home network, and then learn how to monitor systems, and you can learn what all of these metrics mean with just like experimentation, and try to understand what half of this stuff means, and you can learn how to overclock. As you can see, this is an overclocked cluster that I'm running right here, and this cluster is overclocked by 25% for this Raspberry Pi set. And you can see all kinds of stuff. You can try changing the electrical values and see what happens. You can overvolt the thing. You can undervolt the thing. It's yours. You can do like, this is the whole point of a home lab. You can home lab. And really, hardware is hardware. So if you don't know how to work with something like this, you're gonna have a bad time working on a big beefy thing anyways. And like, if you're gonna learn, like, you might not even know if you want to do the career. But really, one reason why we feel comfortable doing a lot of the stuff that we do, because it is expensive to kind of tell people that they should go buy these expensive things. Because what'll happen is someone might start with the kit from us, but then the next thing you know, then they go and buy a $2,000 system. And then the next thing you know, that they want to go buy a $5,000 system and build it a few years later. And then it just keeps growing and growing.
Mm-hmm.
But the other reality is it's an industry where you can afford it, though. Which is an interesting thing to say. Now, if you've never worked in this type of course, this is in the advanced sciences, it's not easy work to do, which is another reason why like companies are a little leery to hire people sometimes if they don't have real world experience or something that's like hands-on, because if you don't even know how to like monitor your own home network, forbid trying to monitor forbid trying to monitor something else. Like that's terrifying.
Sure.
So yeah, use cases and things. You can learn how to use something like Docker. And you can learn you can learn how to make your own development suite, basically.
So where are you going now? What is this? What are you showing? What is this that you've navigated to?
So this is basically where the magic happens. This is where you can come in.
And what is this? Is this Docker, Kubernetes? What is this?
So this right here is a tool that lets you work with Docker. And it's designed for where you can actually go and you can pull in little tools called Kubernetes in containers, basically. And this is a great place to develop Kubernetes in containers. And so you can come in here and just build little Kubernetes tests, or build Kubernetes development suites, or whatever you want to do. Or you could just never use Kubernetes if you never wanted to use Kubernetes. If you're just trying to learn, Docker's great to just learn on, just to learn clustering and learn swarming and all these things. And why do we develop? Because I've had people ask me the question like, what's Docker, what's Kubernetes? The real difference between Docker and Kubernetes, they're just like two different companies. You could think of it that way. And they both work with the same kind of technology.
And what technology is that?
It's like you could think of it like Apple versus PC is maybe a good comparison.
Well, sure. So Apple and PCs, they both build computers, right? So what are Docker and Container, like what are those? Or I mean,
Docker
and Kubernetes. Sorry.
So there's a technology of like software computers, and so that's called a container. So if you have a laptop, that's of course a laptop, and then if you have a desktop, then that's like a computer that sits on your desk. And then if anyone's heard of a virtual machine, for those of you who are more technical, then that's where you take a piece of hardware, whether it's a desktop or a laptop, and then it like lets you carve up the hardware on your hardware. And then finally we get to the ability to like run a computer as software, and that's called a container.
Yeah.
So like imagine if you were to go buy like an Apple laptop, right? I have an Apple laptop sitting right next to me, even though I'm not using it right now. It's like, let's say that you want that Apple laptop to also run Windows. It's the same piece of hardware. Like hardware is hardware. An Apple laptop can either use Boot Camp and run Windows, or an Apple laptop can, run OS 10, which is what it runs. And the same technology that we build on is what Apple's building their new systems on too. So really, we're using the same processor types that Apple uses. But really, like, you can put Linux on these different things. In a question, can you use these for edge computing? Do you use cases for...
Do you have use cases?
Oh, yeah. Use cases for edge computing. Edge computing is awesome. So that's a good question for anyone who hasn't heard of edge computing. Let me whiteboard what edge computing is real quick. So let's just talk about edge, the edge. So these systems are essentially really good for what's called edge computing as well. So for anyone who's running business or interested in learning how to work with certain types of business tools, or maybe you're trying to build your own software suite, your own software platform, and you're a little more entrepreneurial, or maybe you just like to play with everything, because that's just what some of us do. Then let's talk about edge computing for just a moment here, because what edge computing has to do with is, let's build a little diagram. Let's build a diagram where we say we have a data center. right? And in this data center, this is where we have the primary hosted systems that a company uses. And, you know, we have to protect this, and there's cybersecurity stuff and applications there, and developers and IT all work there together. And
I think that's 2 words.
oh, we can say, is it 2 words? I don't know.
It looks weird as 1 word. Maybe I'm wrong.
I feel like it's 1 word. But anyways, we're saying a data center either way. And so let's say that then this data center, it's probably called a production system, so it's probably running what's called Kubernetes. Let's just put the term out there that you generally will see in the wild. So if you want the right jargon, then this data center likely sits on top of Kubernetes. And then underneath that, let's say that we have a location, like a physical location. Doesn't really matter what the location is. And maybe we have a couple of locations. Let's say that we have like 3 locations. And let's say that we then have another system that's hanging out that has Kubernetes on it. But this is not in the data center. This is a little teeny tiny remote thing, which, let's see, let's mashed potato these together real quick and represent this real quick for science, because reasons. So let's then say that we have these little locations, and we want to make our cloud more like locally accessible to these locations for who knows what reasons. There's various reasons, whether we want to make it easier for development or whether we have like little test environments that are hanging out here. Then basically we end up with this scenario where these are all linked and they all talk, and really it's all still one cloud. So all of this is still one cloud, which I'll just write a little note here. So there we go. You know, we still have all one cloud hanging out here. And then let's say that we wanted to make this a little more interesting, where maybe we wanted to add a few other little cloud clusters, whether it's a different Kubernetes cluster, or we could even have a Docker swarm or something along those lines. And let's say that we mashed potato this to sit on these locations where, you know, and maybe we use this for like development and testing. And this is the sort of thing that you'll see at businesses where they have remote workers, things of the sort. And right now, just currently, whatever infrastructure people have, they use. But a lot of companies provide, you know, developer laptops and developer systems for those who are working on these sorts of things. And so they oftentimes have their own edge computing systems that they can just connect to the cluster with. And really, when you start integrating different like networking clusters together, then this turns into what's called a hybrid cloud. So if we say one cloud, we'll just say cloud and cloud. Different clouds, little different intermingling clouds. If we mix them together like this, then this equals what some will call multi-cloud. Well, multi-cloud and hybrid cloud are different, so this is called hybrid cloud, is what it is. This is you can Google these things. You can Google what this stuff is. But what this does is this is what you'll see for either folks who are working with just like remote developers on operations. But what you'll see oftentimes as well is for like dark sites, or like what a dark site is where you have to have an environment where you have to have a testing location and then like a test environment. And then oftentimes even like another environment that's completely offline. You have to have a way to like test things before you implement, test things before you build. And so this is basically an edge computing model for like a standard model, like modern. Well, there you go. This is home. We could say for each location, this could just be a home worker. And there you have it. Make each one a home worker, and that's pretty much one strong use case. So hopefully that answers like what do you do with that use case, or if that's a good use case. There's a bunch of use cases. There's so many.
So many.
I could Google a bunch sometime, but anyways.
Yeah. Okay.
That's what we've been working on. But more than what we've been working on, like for those who are trying to get into like cloud jobs, cloud careers, like the reason why we've been doing all this stuff and taking open source and creating an architectural platform for it, where now we have this. So it's called a software platform, which is just a whole architecture, which is the Olympiad, which you can go and build your own Olympiad suite yourself and start learning on. But yeah. You can learn how all these different things work. Learn how to build developer environments. Learn how to build production environments at home. Learn all the stuff that people want to hire, and
if you're not sure where to start, we'll teach you how.
That's right, because we teach people how to translate this sort of thing. Basically, it's just an alternative way to, not everyone prefers to work in a collegiate environment with an instructor. Some people just work better just having your own lab. Just different personalities. Everyone's just different. I don't know. And some people like both.
Absolutely.
There's some people who want to have an instructor and they want to have a home lab, which makes sense too, because what if you have all these things that you're learning all the time and no way to test any of it out?
Right. Absolutely.
You know? And so really it's beneficial for students too. So for those of you who are students and you are trying to learn all this stuff, it's just quite a bit.
Yeah. It's an easy way to have your own home lab.
Yeah. And all you have to have is something that can run Docker to get started. Anything that can run Docker, really. And then if you're not sure what to do, you can always just check out our stuff and we'll get you basically bootstrapped on building your own stuff, building your own infrastructure as code. But really, other reasons why I recommend people building infrastructure as code is because if you go over to like places on the internet like GitHub or Docker Hub, this is the last thing I'll show for now. I'll just Google it. It doesn't really matter. Okay, so like if you were to go over to this website called Docker Hub, this is something I've shown before. And you were to just say Ubuntu or something, which I'm typing and you can't see.
There you go.
There it goes. Just letting me move it. So here we go. We've got this Ubuntu thing. So this thing that says like a Docker official images, this is called infrastructure as code. It's a container. There's a lot more to it that, it's a lot more complicated than that. But
Ubuntu is an operating system.
Yeah, and in this
you
case,
can install it in a Docker container and run it on whatever hardware you want.
Yes. Because that's a good way to put it. She puts it much more nicely than I do. That's right. And
that's what I'm here for.
It's like saving like your own saved like software for like these little containers that people use for like cloud standard computing. So then you can build the very apps that people use in the big giant companies at your home, because using Kubernetes and Docker, they're both free. You can use Docker today for free. You can use Kubernetes today for free. So I just always recommend considering building your own Docker lab, build your own Kubernetes lab, and you can go check out our Olympiad architecture. That's free too. This is Free Coaching Friday, so we're trying to point you to all the things that are free. So go get some free things and go learn. Now, one thing that I also would like to announce is that we have been opening up sponsorships.
Speaking of free.
Free! which is actually pretty fun. I kind of like the theme. We're trying to make Free Coaching Friday include more free somehow, which is a complicated thing because that requires us to make more money at the same time.
Yes.
So our goal is to give more free and also make more money. And so we're going to try to find out how to achieve that. And one thing I realized is, like, we can work with building sponsorships where there's people who are trying to build their careers. You don't have the money yet.
Right. You
And
just
then-
don't have the resources.
Yeah, and then there are those who already have spent the time to get to the point where you've established resources and you can start giving back and whatnot. And whether it's like trying to help your staff or trying to help someone else that you know or trying to help a student who seems to, like, you just want to help out for whatever reason, like
See
whoever
the
you
promise and you want to help them
you
get
just
there.
want to, yeah, you just want to help them get there. You just want to help them get into a like, maybe they always talk about cloud, like, oh, I would love to work for AWS, or oh, I would love to work for like one of these many companies that uses Kubernetes, which is pretty much like all the cloud companies.
Mm-hmm.
Start building some of these skills. So we were like, okay, so sponsorships, and we are already at the point where we're going to be able to provide 5 workshops, which we'll detail more next week. But I do want to say here in Free Coaching Friday right now is, like, while our workshops aren't free, we found ways to make our workshops free with the help of sponsorships. And so for anyone who does want to contribute and sponsor someone, we are in the giving holiday, basically. Like, for anyone who sponsors one person for, like, a full, like, suite, or I guess just like a full workshop package for us, then we're going to give someone else from our community a free workshop as well from us. But we're going to start with giving away 5, which we have to now we have to figure out how we're going to give these workshops away. We're going to figure out how we're going to describe how we're going to give these workshops away, and then I'd like to bring I'd like to bring our person who is giving away to
generous donor
to say hello, so that you can say hello when they're ready, and then they'll come on and say hello
That's
to everyone.
coming.
So we have
it's coming next week.
Yeah,
We're really excited to be able to provide some free education to some people.
Yeah. And anyone else who wants to give and, like, come on here with us and say hi to some people who are getting started and, like, never had a career before and just trying to figure out what to do. Sometimes you just need a little help in life. I mean, everyone's needed a little help in life. Even we need help in life. And, like, we build a business around, like, if anyone wants to build a business, you either need customers, or you need investors, or you need backers of some sort. You need sponsors or something. And so, like, sometimes we want to find ways to help people too. And so in our way of trying to give back is we do Free Coaching Friday, and then we try to, find out what we can afford to give and just give. And over time, it'll just be more. So, yeah. So let's get ready to do some giveaways. So anyways, we'll talk about that more later, and we're going to be figuring out how to do more sponsorships in the future. But this is a start to something that I'm very excited about. But yeah, just in general, no matter who you are, if you are in a situation where, like, you're trying to get it into a new career and you really can't afford the kind of guidance that other people just can afford, or you can figure something out, like, you can really just hit the Google grindstone and just start, with even our free resources, and let our free resources dig you out of a hole. A lot of our programs are kind of designed for people who are kind of more trying to switch careers. So maybe you don't want to start all the way from the bottom, and maybe, like, resources to either help others or even help yourself for the holidays and things like that. Like, we can help you basically, like, fast track a transition to, like, move from one career to another as well. So that's something that we care about too.
Definitely.
But anyone can learn. This Free Coaching
skills
Friday.
are translatable no matter what sort of skills you have.
Yeah. And so we just want everyone to know, like, how can you actually start learning things? And you can start learning things with Docker and Ubuntu.
Cool.
For free.
For free.
All right. Well, thanks, everyone. And we'll catch you again.
Yeah, and just last thing, if you are interested in getting your hands on a free workshop and you're not already in the Facebook group, if you're watching this on one of our other platforms, you can find the details on how to join the Facebook group in the video description. So go ahead and do that. Jump into the Facebook group. We'll have more details about how we're going to be giving those away next week. So go and join the Facebook group for all the details on that.
Oh yeah, Facebook group to figure out how to get in the running
Free
for
workshop.
Free workshops. Free. Anyways, this is the end of the free session for the day, but we'll be back with more free things because that's what we do on Free Coaching Fridays.
That's
and
right.
we'll in the cheer of trying to expand Free Coaching Fridays, we'll do our best to keep trying to produce free as best we can.